Up to this point, LWPS executed every program in linear order. That is, LWPS first executes line 1, then line 2, then line 3, and so on. But we can also tell Python to conditionally execute lines of code. This means that certain lines are executed only if some condition is met. If the condition is not met, LWPS will skip those lines. For example, the following statement multiplies variable x by -1. Now suppose that we want to multiply x by -1 only if x is a negative number. We can tell Python to conditionally execute statements using the if keyword. Here's an example. Line 1 asks Python to store -5 in x. Line 2 contains the if statement. The if statement always starts with the word if, followed by a space, the test expression, and a colon. The test is always a Boolean expression. In this example, the test is x is less than 0. If the test is true, then Python executes the statement at line 3, tab 1. If the test is false, then Python skips line 3. In this case, x, which is -5, is less than 0, so Python will execute line 3. In line 3, Python multiplies x by -1. Here's a demonstration. First, let's store -5 in x. Then we evaluate the if statement test, which is x is less than 0. The test is true. And now Python executes line 3. At the conclusion of this program, x is now set to 5. Notice that line 3 is indented. That is, there are spaces that precede the statement. In a Python program, both the vertical position, or the line number, and the horizontal position, the tab number, of a statement are significant. The word tab comes from the tab key on the keyboard. In a word processing program, pressing the tab key usually moves the cursor to the right, creating white space. Tab numbers start at 0. If text is at tab 0, it is not indented. If text is at tab 1, then the text is indented usually by 4 spaces or 1 tab. If a statement is in tab 2, then the text appears after 8 spaces, and so forth. The if statement body is a set of statements that follow the if statement whose tab is greater than the if statement's tab. In this example, the if statement is in line 2, tab 0. The if statement body is one statement at line 3, tab 1. If the if statement test is true, then Python enters the if statement body by incrementing both the line and tab numbers by 1. If the statement test is false, then Python increments line 1, but the tab number is left unchanged. Try changing line 1 to x equals 5 and run the program again and see what happens. For comparison, here's the same program in MIPS assembly. Let's go through this program line by line. Instruction 0 stores -5 in cell 1. Instruction 1 says, if cell 1 is less than cell 0, which is always 0, then jump to instruction 3. Otherwise, move to instruction number 2. Instruction 2 jumps to instruction number 4, or the end of the program. Instruction 3 multiplies cell 1 by -1. This program is not super complicated, but we used a few tricks to achieve the same behavior as the Python program. For instance, Instruction 0 uses the add I instruction to store a value in a cell. Also, MIPS does not provide an if instruction, but we can emulate it with the BLT, or branch unless than, and the jump instructions. Let's take a closer look at instructions 1 and 2. At this point, if cell number 1 is less than 0, then LWCS moves to instruction number 3, which multiplies cell 1 by -1. But if we change the program so that cell 1 is not less than 0, then LWCS will move to instruction number 2, which tells LWCS to jump to the end of the program, thus skipping instruction number 3. As a side note, the BLT instruction is nearly equivalent to the if statement in the Python program, except that it tells the computer to skip instructions when the condition is true rather than false. Alternatively, we can branch when cell number 1 is greater than or equal to 0. Then the jump instruction is unnecessary. But either way, most of us would agree that the Python version is easier to write and understand than the MIPS assembly program.